first exam. Okay. Next week, I'll go over kind of exam procedures, but I did post the exam one study guide here in the announcements. So just go to announcements as students. Our first exam is scheduled for next week on Thursday, September 17th from 6 p.m. to 7:50 p.m. The study guide is posted below. Be sure to go through it over the next week. Okay, exam one review is posted here. So when I built the exam, I pulled questions that are similar to those found on the exam review. Any question about that?
How is the exam gonna work? Like, how are we gonna access it and whatnot?
Okay, so there's two parts to the exam. Okay, and go back in here. So the way that you're going to access the exam is on exam day, it's going to show up here under your assignments. And it says exam one questions and exam one proctorio upload. You're going to click on proctorio upload first. That's going to allow you to do is it's going to allow you to start proctorio. You will need to make sure that you download proctorio from, and you can only run this in Chrome. You need to make sure that you download proctorio, okay, as an extension in Chrome. So you just go here to extensions, more tools, and then extensions, and you just get the proctorio extension. Okay. Once you have that, you're gonna log in here. Okay. And it's gonna say, mine's gonna say preview, but yours would actually be. Let me go to the. Go back home. Let me view this as a student. Okay, so here's the student view, right? And then again, here's, okay, exam one questions, exam one proctorio upload. Again, you won't have access to this until exam day, but you'll go click on proctorio upload, and then it says this quiz is locked until here. Let me show you what it's going to look like. Okay, this is where you'll go in, and then you'll open another tab. Okay, so this is going to start the clock running. Okay, 2 hours, you'll have 2 hours, and it'll start the clock. Okay, then what you're going to do while you're in proctorio, you're going to open up another tab. You're going to log in again. Okay, or what you could actually do is you could go over here to my assignments and just say open link in new tab. That would be easier. Okay, because you're already logged in, you don't need to log in again. Okay, you could even go to home, and there you would find the questions for the exam. So here's the exam one questions. Again, I don't think it's going to let me in until, yeah, you can't take the test. So here you're going to find the questions. So let me show you how this works. Okay, so let me leave student view. Okay, so what you can do, I'm going to click on preview here. Okay, is you get, it says the question one is the instructions for the exam. It says open a new tab. Log on to Canvas and click My Lab and Mastering, or just click on assignment, okay, on My Lab. Okay, okay, click on exam one. I should make that exam one questions. Okay, enter the password business one. After you've completed the exam, please upload all your work. So it'll say choose file here, upload all your work, all questions written out in sequential order as a single doc file or PDF file here. Okay, so you're gonna write out all your solutions for the questions, okay, as you work through it, and then you're gonna upload your work to here. It'll say choose file, you'll choose the file, and then you'll upload that. Your work is worth 50 points and your answers are worth 50 points. Okay, so again, And that's in quizzes. The exam one proctorio upload is in quizzes. Okay. The other one's in assignments. I don't know why this is. I'm gonna actually go back here and this should say something else. I don't know why it's not edited. Okay, open new tag. Okay, log on to Canvas. Click on assignments. Click. It says that. Why is it showing up different? I already edited it. So why is it showing up with the old stuff? Enter business one, blah, blah, blah. Okay. Save. Save. I don't know why it's not. If I preview it, it goes back to the old one. What the hell is wrong with this thing? Or now. It's kind of weird. Yeah, that's weird. Okay, but anyway, you get the idea. It's exam one questions, okay, because you're already in proctorio upload, but it'll be exam one and it says questions on it. And then those are your questions. And then when you're done, you're gonna upload the file. So that's pretty much how it's gonna work. The exam one questions will be here. It'll say you cannot take this test, blah, 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 until test day. Okay. Okay, any other questions about that? Again, the assignments in assignments, actually, let's go back to the home. On exam day, both of these assignments will be here, posted for you. Right here. It says exam one questions. That's where you're going to get the questions and submit the answer. Proctorio upload, that's going to start the clock, and that's where you upload your solutions. Okay. Now you have to put the solutions, or sorry, that's where you're going to upload your work. You're going to have to put the solutions in exam one questions, because this exam one comes from my lab. I'm going to mute whoever that is. Come on. Mute all. Okay. So does that help? Again, this is just like a regular assignment. Like say that I go into assignments and I click on 1.1. Okay. It'll show just like this. It's just like an assignment. You're going to click on the question. Yes, you're scanning your work. Exactly, Aaron. You're going to click on the question. It'll come up. I don't know what's going on. Let's see. But there you go. It's lagging for some reason. Maybe it's because I'm screen sharing that it's laggy. Let me stop my share for a second. Question one. You can do a couple of things. You can take pictures of your work and then put it in a doc file, or you can write all your work out and then scan it and send it to me as a PDF. So there we go. Okay, so it'll be like this. You're going to put in your solution here, but then you're going to upload your work at the very end. Okay, so again, this is where it's going to say the questions. Okay, questions, maybe I'll put questions, solutions. And then the other place is going to be the work. Okay, the upload work. Let me go here. Where is the quizzes? Leave this thing. Okay, so here's Proctorio, upload. I'm going to put upload work, edit. Okay, let's upload. This is where you're going to upload your work. So you have two places that you're working with here. Okay, upload your work. Okay, so I'm going to start that, save it. Oh, oops. That wasn't good. There we go. That profile. There we go. Save it. Time limit, 120 minutes. Restrictions, blah, blah. Okay, that's good. Should be good now. No thanks. Okay, so Proctorio upload work, and then you go into assignments, and exam 1 is the questions/solutions. Okay, I'll be here all during the exam as well. So okay, I'll be in Zoom, and so will you guys. So you can pop in and out during the exam and ask questions. So save that. Okay, so this thing here is where you're going to get the questions, and you're going to put the solution. Okay, so what's the confusion here? Still a bit confused on how the exam will work. So the proctored part will be just like our homework. We'll have to take a photo of our work and send it, just like your homework. Okay, so let me run through it one more time. Okay. So at the very beginning of the day, you're gonna click on exam 1 Proctorio upload work. Okay, that's gonna start the exam. Boom. Okay, and then when you do this, it's going to come up with some directions. Okay, preview the quiz. Okay, it's going to click on this stuff, and I'm hoping that I can get this thing to update. But it says open a new tab. Okay, log on to Canvas. Okay, I logged on to Canvas. You can click on MyLab and Mastering if you really want to follow these directions. Either way, I was just trying to make it easier for you. You can just click on announcements. Okay, open up the, or not announcements, assignments, and the assignment will be here. You can either access it through MyLab or you can access it through Canvas. But it'll come up with the questions. You're going to need to know what are the questions. So you're going to click on the questions, and then it says click on exam 1 questions. I don't know why it's not updating. It should say exam 1 questions there. And you're going to enter the password business 1. So it'll, on exam day, you're going to click OK here. It'll say, okay, and then it'll ask for a password. You're going to type in business 1. And this is where it's going to be just like your homework. Just like your homework. At the same time, you're going to be working out on a piece of paper your solutions. Okay, when you're all done taking the exam, you're going to go back here and you're going to upload your work. See how it says Proctorio upload work? This is your work. Your original work will be uploaded in a file. What type of file? A doc file or a PDF. A doc file if you want to post images in a doc file, or a PDF file if you want to scan your work.
Professor Holtman.
Yes.
I have a question. So let's say I'm working to the final minute of the test. Do I have to turn in my work exactly before the time ends, or can I turn that in after?
You have to turn it in. You'll have the test is supposed to end at 7:50. You'll have between 7:50 and 8 o'clock to turn in your file.
Thank you.
Sure. Okay, sounds good.
How many questions in the exam?
It's 15, I believe. 15 questions. You have an hour and 50 minutes to do 15 questions. Some of them are short answer, you know, so some of them are take a little bit more calculation. Okay, but you should have more than enough time to finish it. Okay? Makes sense? Hopefully it makes sense. Okay. Let's go over material. It'll make more sense on exam day, because you'll see, oh yeah, I have access here and I have access here, and so that's, you know, you're not gonna click on the number 15. What are you saying? Why can't I not see anything here? Oh, because I'm sharing my screen, that's why. Okay, what did you want? Yes, 15 questions. Oh, yes, 15. Yes. Okay, whatever. Okay. Goodbye. Okay, let's begin, shall we? Today's lesson on derivatives. Okay, and we're gonna make things a lot easier today, because we're going to show you quick ways to find derivatives, right? So before, all we had was the definition of derivative, and that was a pain. The definition of derivative is a pain to get. Will the test be based on the study guide? Yes, I said that already. Yes. You probably didn't catch it. Okay, because using the definition of derivative is, like I said, is a pain in the butt. So are you giving us practice for this exam? Sorry, what did you say? Are you giving a practice for this exam, and are you working it with us? Okay, I don't know where you were at the beginning. Were you late? I would check the announcements on Canvas. Okay. I just sent an announcement with the study guide. And I will be going through select questions on it on Tuesday. However, you need to have it worked between now and then. Hopefully that answers that question. Okay, where's my, let's get rid of that. Let's go in here. Okay. Do we have homework this weekend? Yeah, it's called the study guide and all the 4 assignments from this week. So you actually have more homework than normal. Do you guys not have access to Canvas? Can you not see what's due? Yes, you can. Okay, good. It's like Bob the Builder. Yes, we can. Can we fix it? Yes, we can. Boom. Good. All right. I'm gonna have some weekends. I need a little refresher. There we go. Any other questions that could be answered if you looked at Canvas? Just throw them out there. I'm just messing. Okay. Let's get into this, shall we? We shall. Okay. Get rid of this thing. Boom. Boom. Yes, go away. What? $1.5. Power rule. Do you want a cracker? Here, have a cracker. Okay, and go away. Okay, power rule. All right, so from the definition of a derivative, okay, i.e. f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. We can establish the following patterns. Okay, so does anyone remember what the derivative of x squared was? What's the derivative of x squared? Any ideas? Two x. Thank you, Darlene. It's 2x. Okay, what about x cubed? We did both of these using the definition of derivative, x cubed. Close. Yeah, 3x squared. Exactly. Okay. Okay, what about x? Remember what the derivative of x was? 1.
Just
Very
one.
good. Okay, thank you. Okay, what about a constant?
It's a
What about
constant.
a constant? Oh, it's 0, right? Yeah. 0. What about 1 over x? Remember what that was? Yeah, that's negative 1 over x squared. And then 1 over radical x is 1 over 2 radical x. So these are the common ones that I wanted you to memorize. Okay, these are the common ones. So we're going to look at how to get all of these using one rule, and that's called the power rule. So if I were to continue this pattern, you would see an interesting pattern arise. If I took the derivative of x to the 4th, it would be 4x cubed. X to the 5th would be 5x to the 4th, and so on. Okay. And so if I took x to the nth, this would be n times x to the n minus 1. Does that make sense? Okay, I put the power in front, right? I put the power in front, and then I subtract 1 from the denominator, or from the exponent. I gotta stop reading these things. Okay, one more. That's it. That's it. Okay. They're probably not very good for my dogs, but whatever. They're probably not very good for me either. 100% whole grain wheat in the wheat thins. Okay. So here's the deal. Okay. Here's the deal with these. Okay. So we say that the derivative with respect to x of x to the nth power is equal to n times x to the n minus 1. This is called the power rule. Okay, so we can get all of these on this page from the power rule. You're like, well, how can we get these guys over here, these special cases with the power rule? Let's try it. Let's try it. Okay, so I want the derivative of x to the first power. What's that going to be? Derivative of x to the first power. Well, what's n in this case?
1.
1. Okay, and then what's 1 minus 1?
To the 0, which is
Yeah,
1.
0. So this is 1 times x to the 0. What's anything to the 0 power?
1.
1. What's 1 times 1?
1.
1. So what was the derivative of x?
1.
1. Okay. So the derivative of x is 1. Okay, let's try a constant here. Constant. C, constant. Okay. So let's go 0 in the exponent, right? Or constant. So sorry, let's do this. Let's write it like this. C times x to the 0. Because again, what's x to the 0? That's just 1, right? Okay. Let's bring the exponent in front. Okay, and this becomes c times 0, x to the negative 1. Well, what's anything times 0? Well, that's 0. So c, okay, the derivative of c, okay, is equal to 0. So constant becomes 0. Okay, what about 1 over x? Let's try d dx of 1 over x. This becomes the derivative of x to the negative first power. Okay, let's bring the negative 1 in front. That's negative 1x to the negative 1 minus 1. We're going to go down, always go down a power. That's negative 2. So this is negative 1 over x squared. And we kind of already knew that from the definition of derivative. But again, this is just verifying all of these things that we know. And that goes to that. 1 over x goes to that. Okay, constant goes to that. What about radical x? Radical x. So let's find the derivative of radical x. Okay. Well, I can rewrite this as an exponent. This is x to the 1/2 power. So let's take that 1/2 and let's put it in front. That's 1/2 times x to the 1/2 minus 1. 1/2 minus 1 is negative 1/2. So this becomes 1/2 x to the negative 1/2 power, which is the same as 1 over 2 x to the positive 1/2 power. But what is x to the 1/2 power? Isn't that radical x? Yeah. So the derivative of radical x becomes 1 over 2 radical x. Oh, just by the power rule. Okay, so power rule always works there. Okay, let's do some derivatives here. Okay, number 1, differentiate. Okay, each of the following. Okay, so A, y equals x to the 5th power. Okay, so y equals x to the 5th power. We're going to take the derivative of this thing. We want y prime equals Okay, y
Is that-
prime is equal to
5x to the fourth.
exactly 5x to the fourth.
Professor, that shortcut isn't always available to be used, right? Only when
Well,
h.
It is.
It is.
If you're dealing with something that has a power.
Oh, okay.
Okay, y prime equals 5x to the fourth. What about b here? Okay, y is equal to 1 over x to the fourth power. I'm going to rewrite this as x to the negative fourth power. So I'm going to go y prime is equal to negative 4x to the negative fifth power. I always go down a power. Go down a power. Always subtracting 1 from the previous power. Okay, C. Y equals the fifth root of x. The fifth root of x. Okay. Let's see what this looks like. This is y equals x to the 1/5 power. Okay, so what's y prime going to be equal to? Well, y prime is going to be equal to 1/5 x to the 1/5 minus 1. Okay, so that is equal to 1/5 times x to the negative 4/5. Okay. I'm going to bring this down below. This is 1 over 5x to the 4/5. And I always leave things the way that I found them. Okay, if I was given a fifth root, I'm going to leave it as a fifth root. The way I do that is I break this up. X to the 4/5 is equal to x to the fourth raised to the 1/5 power. So I can get my fifth root that way. Okay, so this is 1 over 5 times the fifth root of x to the fourth power. Okay, and then D here is what is y equals x to the 0.7? Okay, power. Well, let's just use the power rule here. Y prime is equal to 0.7x to the 0.7 minus 1. Okay, so 1 minus 0.7 is 0.3. So this is 0.7x to the negative 0.3. Okay, nice, nice. Okay, so that's going to be 0.7 over, okay, x to the 0.3. Okay. Okay. I'm going to rewrite this a little bit nicer. I don't like having decimals and fractions together. And I know that 0.7 is the same as 7/10. So I'm going to write this just a little bit nicer and go 7 over 10 x to the 0.3. Okay, so just kind of turn that decimal into a fraction because I already had a fraction. I already had a fraction bar. Okay, let's look at another rule here. Okay, what happens when we have a constant times a function? Okay, derivative of a constant times a function is the same as the constant times the derivative of the function. I think we talked about this with limits too. We take the limit of a constant times a function is the constant times the limit of the function. Well, a derivative is just a fancy limit. It's a special type of limit. So the rules should stay the same. Okay, so number 2 here, find the derivatives. Okay, so A, 7x to the fourth. So what's the derivative of 7x to the fourth? Well, it's just going to be 7 times the derivative of x to the fourth, which we saw was 4x cubed. Right? So we could go like that if we really want to. And so this is just 28x cubed. Okay, B, what about negative 9x? Well, what's the derivative of negative 9x? Well, what's the derivative of just x? Derivative of just x is 1, right? So the derivative of negative 9 is just negative 9 times 1, which is negative 9. Okay, let's put C over here. Okay, what about the derivative of 1 over 5x squared? What's that going to be? 1 over 5x squared. You can think about this as 1 over 5 times 1 over x squared. Okay, or we can think of this as 1/5 times x to the negative second power. Now I want to take the derivative of this, d dx, of this thing, right? Okay, so this is going to become 1/5 times negative 2 x to the negative third power, which becomes negative 2/5 x to the third. I'm going to bring that negative third down below, and it becomes negative 2 over 5x cubed. That's a 5. Okay. Okay, so let's look at number 3 here. Okay, for VR, okay, equaling, okay, it's a V is a function of R, okay, 4/3 pi R cubed, okay. Okay, this is the volume of a sphere, I want to say, yeah, it's the volume of a sphere. Okay, so V sub R, volume is based on the radius of the sphere, so volume of a sphere. Okay, so let me draw this out a little bit better. Okay, so we have the radius. Well, whatever. It's just based on R. Okay, so R. Okay, so as the radius gets bigger, the sphere gets bigger and the volume gets bigger according to this formula. Okay, so we want to take the derivative with respect to R here. Okay, ddr of V sub R is equal to ddr of 4/3 pi R cubed. Okay, we're taking the derivative with respect to R. Okay, so R is the variable here. So this becomes V prime of R, okay, for the left side. And then this is going to be, use the power rule. Well, 4/3 pi, that's just a constant. So this is 4/3 pi. The derivative of R cubed is going to be 3R squared. Well, that's nice. So the 3's cancel out, and I'm left with V prime of R is equal to 4 pi R squared, and this is actually the surface area formula. So we went from volume formula, this guy here is the volume, and we took the derivative and we got the surface area. So that's kind of cool. Okay, it's also called the instantaneous rate of change. This derivative is the instantaneous rate of change. Okay, I don't know if we've talked about instantaneous rate of change yet, but remember the average rate of change was this guy, right? So let's say that I'm driving a car, okay? Let's say that I'm driving a car, okay? And I start off kind of slow, and then I I get up to a cruising speed, and then I increase, and then I get up to another cruising speed. And then I exit the freeway, and I go down. Okay. So, is that what I want to do? Nope, that's not what I want to do. Sorry. I don't want velocity, I want distance. Okay, so I start from home and I'm gonna end my total distance, right? So I'm gonna start off pretty slow, and then I'm gonna start to speed up. Okay, and then I'm gonna slow down, and then I'm gonna speed up again, and then I'm gonna end. Okay, I'm gonna end by coming to a complete stop. Okay, and this is distance, and this is time. Okay, total distance versus total time. Okay, so how did it go from cubed to squared? We took the derivative. That's how we subtracted a power when we took the derivative. Okay, because it wasn't the derivative before, and then it became the derivative when I did that 3r squared. Okay. Sure. Okay, so notice that from here to here, I travel a certain distance over a certain amount of time. So change in distance over change in time. Okay, and that would give me my average. That would give me my average rate of change over these 2 points. Okay, how can I use this analogy here? Well, let's say that after 5 seconds. Okay, so let's look at time here. We'll say 5 seconds and then 10 seconds. Okay, so 5 seconds and 10 seconds. Okay, so after 5 seconds, I'm traveling 30 miles per hour. After 10 seconds, I'm traveling 60 miles per hour. Okay, and so here's the idea. Okay, is that what's the average rate of change? Well, I'm going to take the 60. Okay, the average rate of change here. Okay, well, let's not do miles per hour. Let's just do miles. Okay, or let's do meters. Let's make these meters because that's going to make a whole lot more sense. Okay, so yeah. So if I do 60 minus 30 over 10 minus 5, right? What is that going to give me? That's going to give me the meters per second. Okay, that's the meters per second that I'm changing. So this is 30 over 5, which is 6. The change was 6 meters per second. Okay, on average, I went 6 meters per second. But if I want the instantaneous change at, say, 7 seconds, the instantaneous change is the tangent line here to the graph. And that's the derivative. That's the instantaneous change. So again, the way to think about this is say you're looking at your speedometer in your car, right? And we'll just say at time 0, okay, at some specific time value, whatever that is, okay, you're going 30 miles per hour, okay? After another time increment, maybe it's 1 hour, you're going 60 miles per hour, okay? So on average, what was your average rate of change here? What was your average rate of change? Well, the average rate of change would have been 30, you know, if it's miles, right? 30 miles, right? In 1 hour, right? So the average rate of change, well, let's just do miles here. I keep messing this up. Okay, so you're going 30 miles. You've gone 30 miles at time, let's do time 1 and time 2. Okay, time 1 and time 2. Because it doesn't make much sense to go 30 miles at time 0. Okay, but at time 1, you've gone 30 miles. At time 2, you've gone 60 miles. So you've traveled 30 miles in 1 hour. So that's 30 miles per hour. Okay, in the first hour, you've gone 30 miles. In the second hour, you've gone 30 miles. Okay, but your speed doesn't necessarily need to be constant here. Okay, to have this occur. I could start off and then after 1 hour, I'm at 30 miles that I've gone, okay, the distance. And then after, I could have got a cheeseburger here and not have traveled anything, right? So cheeseburger right here, boom, we're staying at this distance of 30 miles. But then I speed up real quick and I'm at 60. Okay, so my speed doesn't have to be constant here. It could vary in between these points, but on average, what did I travel? On average, I traveled 30 miles per hour. Okay. At one point though, in my journey, I will have traveled at least 30 miles per hour. I could have gone slower. I could have gone a lot faster. But the average was 30 miles per hour. So that's called my average rate of change because I'm doing this average distance over change in distance over time. If I take the derivative, I get something called an instantaneous rate of change. And that's like looking down at your speedometer, okay? Because what's happening there is it seems instantaneous. It's really not. What's happening in your speedometer is you have a magnet on your wheel, and then you have on the other, posted on the other side of that magnet is another magnet, and as your wheel goes around, spins around, it sends an electrical pulse between the magnets, and every time this goes around, right, it shows that it's done 1 revolution, right? And it can calculate the circumference of your tire. It knows the circumference of your tire. You just plug that in, and then it says, oh, you went a certain amount of distance in, say, 1 second, right? So say it went 2 feet in 1 second, and boom, that would be your speed that it's calculating. You went 2 feet in 1 second, every second, right? And so it seems instantaneous, but it's really not, because as the faster and faster you go, the more time that it's passing those magnets, the quicker that computation is being made. And so maybe then you're going 6 feet, right? You're going around this thing, right, 3 times per second, right? So you've gone 6 feet in 1 second, right, per second. So then it just calculates your speed based on how many times these 2 magnets are passing each other, right? 6 feet per second. So if you're going 3 times as fast, it just knows that in the same amount of time, it has passed that magnet three times as many times. And so really what's happening here is you're having these calculations, this distance over time, but you're having this time be so incredibly small. This gets smaller and smaller as your speed increases, because the change, because every time it passes this magnet, it takes a record, boom, of it says, oh, at this time it passed the magnet, and then it goes again around and it hits the magnet again, and then it takes another reading, boom, and what it does is it calculates that change in distance. So say we went, we went 0.06 feet in 0.01 seconds. But then it just does the math and that says, oh, you went 6 feet per second. Okay, and then it doesn't do that. It changes that into a miles per hour, which 88 feet per second is 60 miles per hour. And then it just shows up on your dashboard. It's a little less complicated than this because it doesn't even go to the feet per second. It automatically jumps to the miles per hour. Okay, but just for reference, if this thing is passing 88 times, and say the circumference of your tire was 1 foot, which it isn't, but just to make this, if this is having revolutions of 88 times in 1 second, then you're going 60 miles per hour. And that's all it does. All it does is calculate the number of times this magnet passes every second, and it calculates your speed. And when you look down at that speedometer, what you're thinking, because it happens so fast, you're thinking it's instantaneous. It's an instantaneous rate of change. It's the same thing that we did with our limit, right? Is we got the change in h, right? Because this was x, and this was x plus h. We had that change in h go extremely small, right? We had h go to 0, where the change seemed like it was instantaneous. It's an instantaneous rate of change. Okay. So to you, to your mind, you're perceiving it as instantaneous when you look down at your speedometer. However, it's not instantaneous. It's just happening in such a fraction of a second that you don't see the changes in speed. Okay, you don't see the instantaneous changes in speed. It just looks constant. That, oh, okay, I'm traveling at 60 miles per hour. Because you're going at a constant speed. What you're not seeing is the change in distance over the change in time. Okay, and so you're just having that constant speed. Okay, because the number of revolutions that tire is going around is remaining constant. Okay, so okay, I guess sure. Okay, so we know that v prime r is equal to 4 pi r squared. Okay, and so we want to know, well, what's the rate of change? What's the instantaneous rate of change when the radius is equal to 1.2? Say that I'm blowing up a balloon, right? Say that I'm blowing up a balloon. I want to know when r is 1.2, how much is the volume changing with respect to the radius? If the radius is changing, okay, I want to know how much is the volume increasing at when the radius is 1.2. So I'm just gonna plug this in, r 1.2 for r, and the instantaneous rate of change, which say the volume was in meters. Okay, so the volume here is going to be in meters cubed, right? Meters cubed. So what's the instantaneous rate of change? Okay, it's whatever per whatever unit that you want. Okay, so so this is going to be 4 pi times 1.2, and then squared. Okay, so the instantaneous rate of change. Okay. Okay, this is going to be 4 pi times 1.44. So that's 5.76 pi. Okay, and so if the volume was in meters cubed, then the derivative is 1 less. It's 1 less. See how the meters here would be squared and not cubed. And so that's square centimeters. Okay, it's like saying dV/dr, right? What's the meters of volume? Well, the meters of volume is meters cubed. What's the units of the radius? It's just meters. And so that's going to cancel one of those out, and I get meters squared. This should be meters, sorry. Meters squared, not centimeters. Okay, and so this is approximately, if I plug in the pi, that's approximately 18 square meters is the rate of change. Okay, this is the rate of change. Okay, so let's look at our last rule here for this section. Okay, the derivative of a sum or difference derivative of a sum or difference, okay, d dx of f of x plus g of x. You just take them individually. You take the derivative of f of x, and you take the derivative of g of x. You just break it up into the derivative of the first and the derivative of the second. Okay, the same with a sum, with a difference. Okay, d dx of f of x minus g of x is equal to d dx of f of x minus d dx of g of x. Okay, so let's look at this in practice. It's going to look like. Okay, number 4 says find each of the following derivatives. Okay, A. Let's find the derivative of 5x cubed minus 7. Okay, so I'm just going to take the derivative of the first term and the derivative of the second term. Well, what's the derivative of 5x cubed? Well, that's 5 times the derivative of x cubed, which is 3x squared, minus the derivative of a constant. But we know that all constants have a derivative of what?
A 0.
Yeah, 0. Thank you. Okay. And so this is just going to be 15x squared is the total derivative. Okay, let's look at B here. Okay, let's if y equals 24x minus radical x plus 5 over x, I want to find the derivative here. Y prime is going to be equal to what? Well, what's the derivative of 24x? The derivative of x is 1, so 24 times 1 is?
24.
24. Okay, minus the derivative of radical x. What's the derivative of radical x? Well, we already know that. That's 1 over 2 radical x. That's one of those we should have memorized. And then this is plus 5 over x. Think of this as 5 times 1 over x. The derivative of 5 times 1 over x, that's going to be negative 5 over x squared, because once again, we should know what the derivative of 1 over x is. That's negative 1 over x squared. Okay, we could also use do these based on the power rule if we really wanted to, but I'm not going to. Okay, so this becomes 24 minus 1 over 2 radical x minus 5 over x squared, and that's the derivative. Okay, number 5. Find any points on the function f of x equals negative x cubed plus 6x okay, where the tangent line is horizontal. All right, negative x cubed plus 6x. Okay, where the tangent line is horizontal. That means to have a horizontal tangent, okay, means that the derivative or the slope of the tangent line has to be 0. We want to know, where is f prime of x equal to 0? That's the question that we're asking. Well, we need to find out, well, what's f prime of x? What's the derivative of x here? Well, derivative of x cubed is 3x squared. That's going to be negative 3x squared. Derivative of 6x is 6, and I want to set that equal to 0. Okay.
Professor, you're
Oh.
searching for f prime 0 because that's the
Oh, you know what?
slope, right?
This is, say it again?
You're looking for f prime 0 because that's the slope of the tangent line, right?
Exactly, yes.
Okay.
So m's are 0, 0. So I want this to be 12, so it comes out nicer. Okay, 6 times x squared, the derivative of 6x squared is 12x. Okay, now I can factor out a negative 3x, and this becomes x minus 4 equals 0. Okay, so two things that could get me 0 here. One is negative 3x equals 0. If this thing is 0, then that goes to 0. Or x minus 4 equals 0. If that's 0, then that also goes to 0. Okay, so divide by negative 3, x equals 0. Or, okay, add 4, and x equals 4. So at x equals 0 or x equals 4, we have horizontal tangents. Okay, so what are the points here? Well, to find the points, we have to plug these back into the original function. Okay, so what was the original function? F of x is equal to negative x cubed plus 6x squared, right? That's 6x squared, okay. So let's plug in f of 0, see what we get here. Well, I think that's just 0, right? 0, negative 0 cubed plus 6 times 0 squared equals 0. Okay, so 0, 0 is where this goes. This has one horizontal tangent here. Okay. Okay, at point 0, 0, there's a horizontal tangent. Okay, what about when x is 4? This is negative 4 cubed plus 6 times 4 squared. This is negative 64 plus 6 times 16. Okay, and that's 96 minus 64. Negative 64 plus 96, which is 32. So this is going to be at 4 comma 32 is another horizontal tangent. Okay, so let's see if that works. Okay, so let's so what was it was 4 0 0 and 432, right? 0 0 0 0 and 432, yeah. Okay, and the original function was this guy here. So let's go to Desmos real quick. And let's look at 0 0. Okay, let's look at the function. Okay, the function was y equals y equals negative x cubed, I believe, right? Negative x cubed. Oh, no.
6x.
Cubed. Keep hitting the wrong thing. Okay, plus 6x. Okay, and so, sorry, 6x squared. There we go. Okay, so as we can see, we do have a horizontal tangent at 0, 0. And if we go up here, we do have another horizontal tangent at 432. Okay, so horizontal tangent, I could say y equals 32 is a horizontal tangent here. So y equals 32 is a horizontal tangent. Okay, you can see that that tangent line is horizontal there. Okay, and y equals 0 is also a horizontal tangent. Okay, which is just the x-axis. Okay, that's also a horizontal tangent, y equals 0. Okay. Boom. So, like so. There we go. Okay, so those are my two horizontal tangents. One was at 0, 0, and one was at 432. So it does make sense. Okay, we use the derivatives to find the horizontal tangents there. Okay, let's change gears. Let's talk about the product and quotient rules. Okay. Okay, this is 1.6. Okay, product and quotient rules. Okay, so if I have the product of two functions, let's make this h of x.
Yes, you're not sharing your screen.
Oh, thank you. Okay, better. There we go. Okay, so if I have the product of two functions, let's call this f of x times g of x. Okay, then what we do is we have to find the derivative. We have to take the derivative of the first times the second plus the derivative of the second times the first. Okay, so that's that, and this is called the product rule. Okay, when I have the product of two functions, I do the derivative of the first times the second plus the derivative of the second times the first. Okay, okay, number one. Find the derivative h prime of x if h of x is equal to x to the fourth minus 2x cubed minus 7. Oops. Minus 2x cubed minus 7 times 3x squared minus 5x. Okay, h prime of x is equal to, okay, derivative of the first. That's 4x cubed minus 6x squared plus 0, okay, minus 0, okay, times the second, okay, which is 3x squared minus 5x, plus the derivative of the second now, which is 6x minus 5 times the first, which is x to the fourth minus 2x cubed minus 7. Okay, so This is the derivative of the first times the second plus the derivative of the second times the first. So let's h prime of x, this is equal to 4x cubed minus 6x squared times 3x squared minus 5x plus 6x minus 5 times x to the fourth minus 2x minus 2x cubed minus 7. And that's about as far as I'm going to go on that one. Okay, let's try, oops, that's weird. Let's try the next one here. Okay, number 2. Okay, find f prime of x if f of x is equal to x squared plus, x squared plus 4x minus 11 times 7x cubed minus radical x. Okay, so let's take the derivative of this thing. So f prime of x is equal to derivative of the first is 2x plus 4. Okay, the 11 could become 0. Go to the first times the second, which is 7x cubed minus radical x. Okay, plus the derivative of the second. This is I'm gonna bring the 3 down, which is gonna make that a 21. So that's 21x squared minus radical x, which I know what that is. That's 1 over 2 radical x times the first, which is just gonna be x squared plus 4x minus 11. And that's about as far as I can go with that one. Okay, quotient rule. Let's look at the quotient rule real quick. Okay, quotient rule. Okay, so what's the quotient rule here? Okay, well, let's let h of x at this time be equal to f of x over g of x. Okay. So how do I find h prime of x? Okay. H prime of x, that's now going to be the derivative of the top times the bottom minus the derivative of the bottom times the top. So very similar to the product rule, except that instead of doing first, second, we're doing top, bottom. Okay, and there's a subtraction sign. Don't forget the subtraction sign. Okay. Okay, note the subtraction sign all over the bottom squared. Okay, all over the bottom squared. Okay. Let's see if this works. Okay, let's do one that we already know the answer to. Okay, let's find let's say that q of x, do number 3 here. Okay, let's say that q of x is equal to x to the 5th over x squared. I already know what the answer to this is. How do I already know what the answer to this is? Well, because if I simplify this, I would get x cubed. And what's the derivative of x cubed? Isn't that just 3x squared? Right? If I simplified this, I would get 5 minus 2, which is 3. Okay, but let's see if we can get this thing out by using the quotient rule. Okay, it's just good practice. The derivative of the top, what's the derivative of the top? 5x to the 4th times the bottom minus the derivative of the bottom, 2x, times the top, x to the 5th, all over the bottom, which is x squared, squared. Okay, that's the quotient rule. Okay, let's simplify this thing. This is going to be 5x to the 6th minus 2x to the 6th all over x to the fourth. Okay, so this is going to equal 3x to the sixth over x to the fourth. Well, 6 minus 4 is 2. So this becomes 3x squared. Same as we had got before. Okay. Let's try the next one here. Okay. We have f of x is equal to 1 plus x squared over x cubed plus 1. Okay. Or I'll just do x squared plus 1 over x cubed plus 1. Makes a little bit more sense. Okay, let's find the derivative of this. What's the derivative of the top? 2x times the bottom, x cubed plus 1, minus the derivative of the bottom, 3x squared, times the top, x squared plus 1, all over the bottom squared, the whole thing squared. Okay, let's see if we can clean this up at all. Okay, this is, distribute that. That's going to be 2x to the fourth plus 2x. Distribute the negative and this thing. Okay, that's going to be negative 3x to the fourth. Okay, and then it's going to be minus 3x squared. Right? Yeah. Okay, so 2x to the fourth minus 3x to the fourth, that's negative x to the fourth minus 3x squared plus 2x. So that's what the top is going to be. All over the bottom, x cubed plus 1 squared. Okay, so this thing here is just the top. Okay, it's the numerator. Okay. And then I could factor out a negative x if I really wanted to. See if this thing's going to factor any further. I don't think it will. I could factor out a negative x, and that would give me x cubed plus 3x minus 2. Okay, and that's not going to factor any further. X cubed plus 1 squared. Okay. Now, how are we going to use this thing called the derivative? Let's get into the application. Okay. Let's start talking about business. Okay, let's get down to business. Okay, as they say. Okay, the total revenue function okay, is given by R of X, which equals the unit price times the quantity sold. Okay, so think cups of coffee, right? So it's $3 per cup times, 500 cups, right? That's going to give me my total revenue, right? Okay, so that would give me what, $1,500? Does that make sense? Okay, unit price times quantity sold gives me total revenue. Okay, so the unit price we're going to call little p. Okay, I'm going to put a little tail on that so you know it's a lowercase. Lowercase p of x, that's going to be my price function, times q of x, which is my quantity. Okay, or actually we'll just put x. X will be the number, the quantity sold. Okay, this is in terms of number of cups sold. Price times, times, price for each cup, each item times the number of items. Okay, so X is the number of items. Okay, items sold. Okay, so this R of X is going to be equal to, okay, X times the price function, the price evaluated, okay, for X items. Okay, it's the number times the price at X items being sold. Okay, because sometimes the price varies depending on how many you buy, right? So that's why it's a function of X. Okay, because the price could vary. The price could vary based on quantity, based on number bought, right? If I buy, say 20 pencils, maybe each pencil is 10 cents. But if I buy 2,000 pencils, then maybe each pencil is 1 cent, right? Does that make sense? Okay, or maybe 9 cents, I don't know. They're gonna give me some sort of discount for buying more. Okay, they don't have to, but generally that's the case. Okay. So this is called the revenue function. Okay. Now the profit function, the total profit function, is capital P of X equals the revenue minus the cost. Total revenue minus total cost. Okay. We'll go like this. Total revenue minus total cost. Okay. And they're both based on number of items sold. So this is R of X minus C of X is the total profit function. And we could say that P of X could be okay, is X times P of X minus C of X. Okay, and there could be fixed and variable amounts in our costs as well, which we'll get to later. Okay, let's talk about average cost, revenue, and profit. Okay, average cost, we say is C of X over X. Okay, it's the price per item, or it's the cost per item. Sorry, this is the cost per item. It's the total cost over the number of items, right? So say that it cost me $1,000, but it cost me $1,000 to make 100 items. That means that it's $10 per item is my average cost. Does that make sense? Okay, so total cost over number of items. Okay, the same with average revenue is the revenue over X, and the same with average profit is the profit over X. Okay, okay, let's I don't like how close those are together. Okay, so let's do an example here. Okay, number 6. Okay, Paulson's greenhouse finds that the cost in dollars, of growing X 100 geraniums, I don't know how to spell it, geraniums, okay, geraniums is modeled by C of X is equal to $200 fixed cost plus 100 times X to the 1/4 power in variable cost. Okay, so this is fixed costs and then variable costs. Okay. Okay, based on the number of items created. Okay, the revenue from the sale, of X 100 geraniums is R of X is equal to 120 plus 90 X to the 1/2. Okay. Let's find the average cost and the average revenue and the average profit. Find, okay, average cost function, which we're going to call A of X sub C. We want the average revenue function, which we're going to call A sub R of X. That's average revenue. And then the average profit function. Okay. Average profit function. Okay, so how are we going to do this? Okay, well, what's the average cost function? The average cost function is just the cost function
Over X.
over X, exactly. So this is going to be 200 plus 100 X to the 1/4 over X. Okay, that was easy. Okay, leave it like that for right now. Okay, what about the average revenue function? This is just going to be the 190, right? Or sorry, 120 plus 90 here. This is just going to be R of X over X, which is 120 plus 90 X to the 1/2 over, okay, over X. Okay, so that's that guy there. Now, how are we going to find the profit function? Well, the average profit function is just going to be P of X. Well, let's find P of X. Well, what's P of X? P of X is R of X minus C of X. Okay, so R of X was 120 plus 90X to the 1/2. C of X was 200, right? 200 plus 100X to the 4th. I'm going to distribute this negative sign. This becomes 120 plus 90X to the 1/2 minus 200 minus 100X, that's a 1/4, to the 1/4. So this is going to become 90X to the 1/2 minus 100X to the 1/4 minus 80. That's the difference between 120 and 200. Okay, so this is equal to P of X. So how would I find the average profit function, or A sub P of X? That's going to be 90X to the 1/2 minus 100X to the 1/4 minus 80 all over X. Okay, so that's that guy there. Okay, so now let's use this. Okay, let's use this to let's use this bottom one here to do some calculus. Okay. I want to know what's the instantaneous rate of change of the profit when 300 geraniums are sold. Okay, how fast is the profit changing is really what we're asking. We find our profit, like a profit function, and we want to know at 300 geraniums, how fast is my profit changing? How fast is P of X changing? Okay, and that's going to be the derivative, which is P prime of X. That the P prime of X is going to give me, well, it's going to be a sub P prime of X, but I want to know how fast is that changing, the average rate of change. Okay, we're going to make it an instantaneous rate of change. Okay, that average profit function. So what I want to do is I want to find A, K sub A prime of P of X. I want to find out when X is equal to 300, what, well, X is equal to 3, sorry, not 300, 3. When X is equal to 3, because it's measured in hundreds of geraniums, right? When X is equal to 3, what is, okay, how fast is the offer, is the profit changing? Okay, what is A prime of P of X? How fast is that average profit function changing? Okay, so okay, so we're gonna try to find the derivative of this thing, this thing here up top. Okay, so let's see what we can do here. I'd like to clean this up if I can. So let's do this real quick. Let's break this up into let's not take the derivative yet. Let's do 90x to the 1/2. I could use the quotient rule, I guess, if I wanted to. Yeah, let's use the quotient rule here. Let's do that. Okay, let's just jump right into the quotient rule. What is 90x to the 1/2? How would I find the derivative of the top here? Well, that's going to be 90 times, right? So it's the derivative of the top times the bottom. Okay, so let's find the derivative of the top. Let's use quotient rule. Okay, so derivative of the top is 90 times 1/2 x to the negative 1/2 minus 100 times 1/4 x to the 1/4 minus 1. 1/4 minus 1. I'll just write it like that for right now. Okay, minus 80, but the derivative of a constant is 0, so that's just 0. And so times the bottom, right? Times the bottom. So it's f prime of x times g of x. Okay, it's the derivative of the top times the bottom minus the derivative of the bottom. What's the derivative of the bottom? It's just 1 times the top. This is 90x to the 1/2 minus 100 x to the 1/4 minus 80. Okay, all over what? All over the bottom squared. All over the bottom squared, okay. So, and then I want to evaluate this, okay, when x is 3. I could clean this up a little bit if I wanted to. Okay, so if I wanted to, if I wanted to multiply by the x here, I could do something kind of sneaky. And I would do this. I would do 90 times 1/2, that's 45. This is going to be x to the negative 1/2 times x to the first, right? That x is x to the first, minus 100 divided by 4, that's 25, times x to the 1/4 minus 1 times x to the first, okay? Distribute the negative sign here. This negative 1, that's minus 90 x to the 1/2 plus 100 x to the 1/4 plus 80, right? Okay, all over x squared. Okay, so if I add, if I have two bases that are being multiplied together right here, I can add the exponents, right? So what's 1 plus negative 1/2? Wasn't that positive 1/2? Yeah. So this becomes 45 x to the 1/2 Okay. And then this thing here, this positive one and this negative one will get added, and they'll cancel each other out. So this is minus 25 x to the 1/4 minus 90 x to the 1/2 plus 100 x to the 1/4 plus 80. Okay. All over x squared. So yeah, I can combine some like terms here. 45x to the 1/2 negative 90, that's negative 45x to the 1/2. Negative 25x to the 1/4 and 100x to the 1/4, that's 75x to the 1/4. And then that's plus 80. Okay, all over x squared. Okay, I think I'm ready to plug in my 300 geraniums. Okay, when x equals 3, that's 300 geraniums. So I want to find my instantaneous rate of change for my profit. Okay, my average profit, how is that changing instantaneously? Okay, that's this guy here, right? But we want to plug in 3 this time. Instantaneous rate of change evaluated at 3. Okay. So this becomes, I'll put the 80 in front. 80 minus 45 times 3 to the 1/2, that's radical 3, plus 75 times the 4th root of 3, all over 3 squared. Okay. And if I plug that into a calculator, I would get approximately 11.20. Okay, so it's 11.20 per 100 plants. Okay, so every 100 plants, it's approximately changing. My profit is going up by about $11.20. So here's how I'd write this. I would say the average profit the average profit is increasing by $11.20 per 100 plants or by, what happens if I divide the dollars by 100? Wouldn't I get cents? If I divided this, if we could 11.2 divided by 100, wouldn't that be 11.2? No, 0.1112, or it's going up by, okay, if I divide by the number of plants, okay, I wanted to say how much is this increasing per plant. I could divide it by 100, and it would be 11.2 cents per plant. Okay, when 300 geraniums have been sold, have been grown and sold. Okay. Okay, and that's it. That's 1.5 and 1.6. Okay. Oh, okay. It shouldn't be 300, it should be 3 if you plug in the x. So, yeah. Okay, any questions on this? Let me know, otherwise you're free to go. You're very welcome. Thank you.
Professor, can you scroll up a bit? I got disconnected.
Scroll down.
Yeah, when you started differentiating the average profit.
There we go.
Right there. Thank you.
Thanks. See you Thursday.
Professor,
Yes.
I had a question. For the day of the exam, can I use my iPad to do the work?
No, Chrome. It needs Chrome.
No, I mean like I'm gonna use my computer to do the exam, but can I
Oh,
use
yeah.
the
That's
paper?
fine. As long as you can save it as a PDF, that's fine.
Okay. And then also, I wanted to remind you about Thursday. I emailed you,
Okay.
so I just wanted to remind you.
All right. Okay. Let me, who is talking to me?
Andrina,
Oh, Andrina. Okay. Sounds good.
thank you.
Sure.
Professor,
Yeah.
for the assignments, I thought that I saw had seen that 1.5 was due today. Yeah. Oh, never mind.
It's up to 1.4.
Yeah, 1.4. Never mind now. Got confused.
All right,
Okay.
thank you, Professor.
Yes. Yeah.